Hi, I'm Tom Phillip, Product Manager at Aqua Lung America. Aqua Lung America is responsible for designing and manufacturing buoyancy compensators, known as BCs, not only for America, but for our affiliates and distributors all over the world. There are many steps that go into making a BC, and it all starts right here at Aqua Lung in Vista, California. This is our materials group. They are on a relentless search for new and better materials. The group is made up of individuals from engineering, quality, purchasing, and the product manager. During the meetings, new materials are presented and reviewed, as well as test results from previous materials. Selected materials are subjected to various chemicals as well as agitation. This checks for color fastness, wear, fraying, unraveling, breakdown, and loss of tensile strength. This is our weather tester. Selected materials are subjected to UVA and UVB radiation as well as condensation. This tests for fading and color fastness, material breakdown, and loss of tensile strength. This is a rotary abrasion tester. We study the abrasion resistance of different materials. Standardized tests are used to check new materials as well as those from competitors. Here we see a pole tester pulling apart webbing sewn to fabric. The pole tester is used to check the strength and integrity of a fabric or a piece of hardware. Typical items tested are D-rings, hook and loop, zippers, buckles, webbing, and various threads. A salt fog corrosion tester is used to check the corrosion resistance of components. If something is going to rust, we'll usually know in about 24 hours. This is great for D-rings, zippers, backplates, and grommets. It's also good for clearing your sinuses. We know that our BCs will be subjected to hundreds, if not thousands of dives, and therefore we have created this cycle tester. It inflates and deflates the bladders for thousands of cycles. It checks the strength of the fabric welds. After the cycle test, we will leak check and burst test to make sure the weld is still holding strong. One of the more interesting parts of the process is the ability to design a component on 3D modeling software and then send it to a 3D printer where it is fabricated. The resulting part can immediately be put into service. Here we're measuring the lift capacity of one of our BCs. Each size is carefully recorded. While some competitors overstate their lift capacities, the numbers we publish are accurate. Part of BC development involves diving, lots of diving. We do test dives in the pool and the ocean. We not only test items in development, we also test conceptual products as well as competitors' equipment. Building BCs requires a very specialized knowledge. Knowledge is acquired over time. Aqua Lung does an excellent job retaining talent. In fact, 6 core members of the BC development team provide a total of 156 years of experience. The first is Robert in product development. He's been with the company 20 years. Next is Curtis, an expert in heat sealing technology. He's been with the company for 32 years. This is Sang. Sang is a designer and he's been here 28 years. Lisa is a pattern designer and she's been here 29 years. Olivia builds prototypes and design 24 years. And finally, Rosa, who also constructs prototypes and works in design 23 years. We are now at Aqua Lung de Mexico, where the BCs are built. The first step to building a BC is the cutting of the fabric. The first step in the cutting process happens here. A person, called a marker maker, arranges the individual patterns on a computer in an effort to make the most efficient use of the fabric and minimize waste. Next, the arranged patterns are printed on a large plotter. Here we see several layers of fabric being cut and stacked. The plotter paper lays on top. The fabric is sent to the computer-controlled Gerber cutter, where a knife traveling along an XY axis cuts the fabrics into the individual pieces. Internal support structures, made out of various high and low density plastics, are stamped out with a 62-ton press. To form the bladder, urethane-coated nylon is laid out on a heat-sealing die. It is rolled into a welding machine where radio frequency is used to permanently join the fabric together. The resulting RF weld is stronger than the actual fabric.